Okay guys, so next quadrilateral we have is rectangles, right? So enter that on your special quads chart. If, by the way, if you need a new chart, then just print out a new one, right, for yourself just to add there. Remember, these charts are really helping to organize all of our properties and put them in one spot. So you need this chart with rectangle on it. You need the examples printed out, okay? And now let's go and fill in these, figure out the properties. Okay, so if we go to our rectangle here, one of the things we may or may not remember, the definition of a rectangle is that that there's all right angles. So we'll put that in there as as our first property, is that all angles are 90 degrees. Okay, that's actually what the definition is for a rectangle. Because all angles are 90 degrees, that means that we are going to have, since these two angles are 90 degrees, that means that these two lines are parallel. Since these two are 90 degrees, that means these two lines are parallel. So a rectangle is also going to be a parallelogram. So that's another name for this special quadrilateral. So because it's excuse me, a parallelogram, that means it has all properties of a parallelogram. And I'm going to shorten parallelogram to p-gram. So that means that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other. All those properties we had for a parallelogram are going to be true. So that's going to help us, right, to speed us up. So we don't need to test those properties and see which properties hold true. We know that they're automatically going to hold true. Okay, so if I were going to ask you a question, and let me draw my diagonals in right here. Okay, and one diagonal, second diagonal. I would know, because a rectangle is a parallelogram, we would know that the diagonals bisect each other. So if there's no need for me to measure that, because so this F to E equals A to F, right? Diagonals bisect each other. Okay, so what's going to be a new property for a rectangle? Well, let me show you what the new properties give me. So let me measure this right here. All right, that's 11.7. If I measure this right here, that's 11.7. So we can see that we have in this case we have the two diagonals, and no matter where they are, let me just look at those two measurements. Remember, these measurements are the lengths of the diagonals. No matter where these points are located, you can see that the diagonals are congruent. So we go to our chart and we add that in as one of our new properties. Diagonals are congruent, and that's the most important property we have there, right? Diagonals are congruent for each other, right? Okay, now, right, there are some other little things that kind of come along with this that we could figure out on our own, but I thought would be kind of instead of having you figure out your own, I'll kind of show you. So if I measure A to F and I measure F to E, right, we know that the 15.1 is cut in half, so the diagonals, they bisect each other, right? The diagonals bisect. So that doesn't surprise us that they're both 7.5, right? Now, if we think about this other diagonal, right, it also is bisected, right? Again, diagonals bisect each other. Now, because and you can see that like 7.5 and 7.5 don't add up to 15.1. It's just a rounding issue because of how I chose to have this rounded off. Okay, so don't really worry about that. Here's the important thing, right? Remember, diagonals are congruent and they're bisected, so all these pieces are congruent. So if we look at all these little triangles, we can see that all these triangles then are isosceles triangles. And that's another great property, okay, that the diagonals form 4 isosceles triangles. Diagonals construct 4 isosceles triangles. Okay, man, so that's going to be really helpful as we go about doing these problems. Okay, so let's go and actually do some of those problems. Right, so here are our examples, and if you didn't print these out yet, then go and print it out and then jump back in. Okay, so let's see what we're going to do first. Well, I know that this is a rectangle, that a rectangle is a parallelogram, so opposite sides are congruent. So I'll fill that in first. Okay. I know that diagonals bisect each other, but because it's a rectangle, the diagonals are congruent. So all of these are going to be congruent. Okay, so I'll put those tick marks there. Okay, now let me see, how am I going to find this length? I know I can, because remember, we have a right angle right here. Right? So here's the key. This triangle right here, I'm going to highlight in green, is a right triangle. Okay? So always going to be a right triangle, because it's a rectangle, that's always a right angle. Okay, so we have a right triangle. So we're going to use Pythagorean theorem, or a triple, right, for ourselves, if it's a triple. Okay, so notice that the diagonal there is the hypotenuse, so it's going to be c squared equals 4 squared plus 6 squared. Okay, so it's going to be 16 plus 36, that's 52. If I go and reduce the square root of 52, factors of 52 are 4 and 13. So it's going to be 2 root 13. So this entire length right here is 2 root 13. Now, remember, it's cut in half. If I cut that in half, that's going to be root 13 and root 13. Okay? So that the whole thing is 2 root 13 when put all together there. Okay? So you're going to have to use Pythagorean theorem every time you have a rectangle, right? Always look for that. Get that highlighter out, highlight that right triangle. I'd find that measurement. Okay, almost done here. All right, now we got to get angles. Remember, we were just talking about, right, the property that we have isosceles triangle. So here is an isosceles triangle. I'm going to highlight this isosceles triangle for myself. Okay, notice these are the two legs of the isosceles triangle. These are the two congruent sides. So these must be the congruent angles. Across from the congruent sides are the congruent angles. So that's 38 degrees right there. Okay, if I do 38 and 38, that's 76. Take it away from 180, and I get that this is 104. Okay. This angle then is 76 because of, the intersection there. Okay. Now I have another triangle right here that's isosceles. Now, it's not congruent to the other triangle, you can see, because it has the 76 between those two sides. But if I do 180 minus 76, that gives me 104. Cut it in half, and that gives me 52 and 52. Now, I could have chosen to not use the isosceles triangle. I could have remembered that since this is 38 and this whole thing's a right angle, I could have done 90 minus 38 to get 52. There's a couple different ways to do it. Okay. And it's really just personal preference. 38, this is 52, so that they add up. Okay, this is an isosceles triangle, so these two angles must be congruent. Hey, look, those two triangles are congruent. Remember that we said in parallelograms that we had congruent triangles. These opposite triangles were congruent, so they're still congruent. We could use the alternate interior angles as well to move the angles around. There's lots and lots of different options because it's a parallelogram. And there's not like we always do it this way. You just kind of pick it for yourself. Okay. So I've shown you one. I'm going to do this one, but you might want to hit the pause button and try it on your own before I do it. Okay. Let's see. I always like to do lengths first. So that's 11, that's 11. That's 6, that's 6. Rectangle, so diagonals are congruent, so 6 and 6 there. Okay, for myself. Okay. Highlight my right triangle for myself. There's my right triangle. I can see that the hypotenuse right here is 12, so my right triangle would be 12 squared equals 11 squared plus my missing one. Okay, so notice that in this case the 12, the hypotenuse was given, so that just changes. Okay, so b squared is 23. So this is the square root of 23. And that's okay that it's a radical. There's actually more likely to be a radical than not when you're doing this. Okay, so we have all of our lengths. Notice that there was only 2 lengths given, and we were able to figure out every other length. So it's really kind of nice. As you get these more specialized, you can find more measurements. Okay, so let's see. 134 is that. I'm going to use this isosceles triangle. 180 minus 134, 46. Cut it in half, so I get 23 and 23. Okay. How do I get the rest of my angles? Well, I'm going to use that this is a right angle, and then I'll know that that's 67. 90 minus 23 is 67 degrees, and that's 67. Okay. I could do 180 minus 134. That tells me that's 46 degrees, and 46 and 134. Isosceles triangle, so that's 67. That's 67. Right? 23, 23. Okay. I just find all my missing measures after I get that. Okay. Now, let's say we turn it into a square, right? And if we look at this square, right, remember that a square, and I'll take my properties here, that a square is a quadrilateral in which all angles are congruent. All angles are 90 degrees, so it's a rectangle. And all sides are congruent. So it is a rhombus. So remembering that it's a rectangle rhombus tells us that it has all properties of rectangles and rhombuses. Okay, has all those properties, right? So I can use my property list from the previous ones to help me with this one. Okay. So let's see. Let's do side lengths first. Well, square has all four sides congruent. It's a rhombus, so I put that there. Okay. Okay. It's a rectangle, so we have right triangles. There's my right triangle. Okay, I could do Pythagorean theorem, or maybe you recognize it's a special right. Let's assume you don't recognize it's a special right. That's a just do Pythagorean theorem. Okay, so the hypotenuse is the square root of 32. Right, factors of 32 are 16 and 2, so 4 root 2. So this whole thing is 4 root 2. You cut it in half, and it's 2 root 2. By the way, it's not a surprise that's 4 root 2, because if you have a right triangle with 4 and 4 as legs, remember that that's a 45, 45, 90. Oops, there we go. Okay, so we have all of our lengths. Since this is a rhombus, a square is also a rhombus, I know that these are all 90 degrees. Okay. Hey, wait. Isosceles triangle, 90 degrees left over, so these are 45 and 45. For squares, you just need the measurement, and you can get everything else. It's really kind of easy, right, when it comes down to it, because there's just so many properties there. Okay, all right. Good luck on those examples, folks.